that you can interrupt me if you have a question, or you can drop a message in the chat, and somebody who is part of the organizing team or anybody in the meeting can just let me know, and I will flip back to see the question. So if you have a question, just feel free. Feel free to interrupt. Awesome. So don't wait for me to like pause or wait at the end to ask the questions. This is supposed to be interactive. So if you see something you don't understand, or if I get something wrong, just unmute and I'll be able to know, and we'll be able to make it a productive session. So then the next thing we learned here is, so we were able to add elements and we were able to print the elements that are stored in the array list. The other thing we were able to look at was the ability to retrieve those elements. And here I can say, if I want to retrieve the value 54 from the array list, I can say integer number, the one that I want to retrieve, is equals to numbers list dot get, using that get function. And you can retrieve elements because an array list quote unquote wraps an array internally, hence the name array list. You can retrieve elements by index, the way you'd normally do with regular arrays, or you can retrieve them using some of the custom functions that are provided for you, like retrieving the first element, retrieving the last element. So the most commonly used one is this. So you can say, give me the element at 0. Again, array lists are 0 indexed like regular arrays. So the first element will be at the 0th index, if there's anything like that. So let's try and print that first element. I can say first element will be this number, because we're obtaining it at index 0. And if we run that, we're able to see that it gives us 54, and 54 is at the first index. If we want to obtain a value at the next index, we can just so next number, we can just call the same array list and call a get function on it, and instead of passing index 0, we'll pass in index 1, and that will give us that should give us the second element. So the element at the second index. Yeah, let's call it next number. And if we run this, you'll see that we get 22. And you can clearly see 22 is the next element there. If you try to retrieve an element from an index that doesn't exist, so if I say some number, and I try to refer to an index that we don't have, we already know we have 2 elements. So if I try to retrieve an element at index 200, there's something that should happen here. Anybody want to tell us what will happen if I try to do this from the previous session? Anyone just unmute or drop in the chat? Anyone? What happens? Yes? Yeah, exactly. Thanks for that. So yeah, you get an index out of bounds because you're trying to refer to an index that doesn't exist. So in fact, let me not waste time even trying to print it. So if we try to run that, we'll see index out of bounds exception. If you don't know what exceptions are, don't worry. There's I think after this class, after this particular series of classes on collections, we're going to have one on exceptions. I think somebody else will be teaching that, and exceptions will be explained more exhaustively. So for now, just know it's an error. So if you try and do this, it will cause an error, and the error is index out of bounds exception, which is just telling you that you're referring to this 200 index, that it's out of bounds for an array of length 2, or an array list of length 2. So thanks for that. Then the other thing is, so you can retrieve elements like that. We're able to see some of the functions that are already available under collections, and one of them is just checking if it's empty. And we can do that by, we can check is empty by just calling the isEmpty function. Because essentially this is a collection, so anything that is prescribed with the collection interface should be available for us here. So if I run that, I'll see that isEmpty is false. So if we had not added an element, that will give us true. We can also check the size of this list because it's a collection. So anything that's in collection is declared in the collection interface should be available for us here. And we can call size, and if we run that, we'll be able to get 2 based on the 2 elements that we added. I think that's where we left it. So anybody have a question about what we did? I think this summarizes the recap. This is what we were able to essentially cover. Any question? Okay, so I guess preaching to the choir, so we can move on to the next thing. So we are now just covering basic operations on array lists. So I'll just make another compact file here. And let's say this is ArrayList session v2. So this idea of compact Java files is a very nice thing that was added to the language. So we don't need to worry about creating classes and having convoluted main method functions. So this is nice. So we can be creating as many of these as we need. So today we'll be going ahead and looking at, because what we're essentially looking at is core operations on array lists. So today we are going to continue that that path and explore more operations on array lists. So today we've looked at get. So get is done. We looked at add. We've looked at I think we looked at get and add. So today we are going to look at additional ones. So the first one we're going to check out is an interesting one here, which is a set. So a set is like a cousin of add, except they're different in that if we have a list here, let's say this list stores strings, and the strings would be colors, and it's an array list. So we have a few colors. Oh, there's one other thing that we covered that I need to mention. So we covered one bulk operation, which is the ability to add a list into another list. So let me just demonstrate that real quick before we do that example. So if I have another list of integers, other list here, and this is a separate array list, and it contains some integers. So it contains maybe integer that we don't have on the other side. It has 11, and perhaps it has 1, and it has 18. We can essentially copy over all the elements from this list into this list. Or to make it even more interesting, we can have another list of integers. Let's call that list combined is equals to an array list, and this combined will have this list and this list. And the way you do that is you use the add all function. So with this add all function, you can pass in a collection. It accepts a collection. And since our list is essentially a collection from the theory that we've covered previously, we can essentially say add all the numbers and all the values from numbers list, and we can also say add all the values from the other list. So you can add these two lists, you can add them into this combined list. And now if we print the combined list, let me just print it at the bottom here. So if we say combined, and of course we still have the inbuilt toString function, so we don't need to do any of that ourselves. And let's say this is the main list, which was numbers list, and the other one we have here is, of course, we have other list, and this is other list. So I'm just printing all three of them so that we can see the difference. Okay, this will not compile. Let me just remove it for now. So what we've essentially done is we've taken this list, and we've added it to this to create this combined list. So if we run that, we're able to see that numbers list has 54 and 22. Other list has 11, 1, and 18. The combined list has 54, 22, 11, 1, and 18. So you can take two array lists and smash them together and have a new array list. And you can also add this to an existing array list. So interesting operation. It can become very important for a lot of production use cases. So I think in your head you can already imagine finding yourself in a situation where you need to do this kind of operation. So just know that that's a possibility. One thing I failed to look at also on our recap was the getLast function. So let's see. So we did this get function that would retrieve the element at the index. You can change this with the get first, and you don't need to pass an index now, and you can change this with to get last, and that will essentially jump to the last index. And if we run it, we'll be able to get the same output, which is so first, you see it's first is still 54 and second is 22. So retrieving from this. So you can use that. If the list is so long, or maybe you don't remember the index, you just want the first one and the last one, you can essentially utilize those two functions, and that will make your life easier. Again, if you have any questions, just feel free to interrupt. Okay. So now let's look at this set and add relationship. So we looked at add, and first of all, let's populate this this array list of ours that contains colors. So we have it contain color blue and a few popular colors. Maybe contain color yellow, and it contains orange, and it contains perhaps purple. Okay. Make it a bit interesting. Okay, I can't access that. Thought I could access the emoji tree. Yeah. So now our colors array list has these colors. Let's print them just to be sure. So all colors. So all the colors we have, we can print them like that, again utilizing the inbuilt toString function. And we see it has blue, yellow, orange, and purple. Now, if we are just adding elements to this array list, this is how we would do it. And just like we covered on the previous recap, you can add by index. So you can say add perhaps black at index start with the index and then the value, add the color black at index 0, and this will go to index 0 and add the color black. And if we run it, we should see that at index 0, so it starts with black. Now, there's this other function, set. And what set does, it has it essentially has the same function. It expects the same function arguments as add, in that you pass an index and you pass an element. But this is essentially what you'd call a replacement operation. Replacement operation. In that, if you wanted to replace the value at index 0, we would pass that index, and that will change the value at index 0, hence the name set. So add inserts a new value. So this is where I think it can be clear. So before we added this black color, this was index 0. This was essentially index 0. But when we called add and said, okay, at index 0 add black, blue was pushed down. Let me just go back to. So blue was pushed down to index 2. It was not replaced. Although we were pointing to an index that is already occupied, ArrayList just decided to shift the element backwards and add this as a value. I think, in fact, the technical term is shifting. So it shifted blue from 0, moved it to 2, which means yellow was shifted from 2 to 3, orange was shifted from 3 to 4, and purple was shifted from 4 to 5, so that you can have space for black at index 0. So a shift operation is done when you add to an index that already contains a value. But when you call set, the shift operation is not done. Instead, a replacement operation is done. So let's say we want to replace black with maybe some weird color like maroon. So if we did this and said we want to change this to maroon at index 0, let's see what that will give us. So you'll see now we have maroon, we have blue, we have yellow, we have orange, we have purple. I think you guys can notice that we are missing a color here, which is black. So black has been removed from this array list. It has not been shifted. It has not been. What has happened is maroon went and occupied that space and removed the black color. The same way we can go to index. We can go to where would we can go to index. Let's say index 2. Yeah, 2. And whichever color is there, replace it with no color. And if we run this, we would see that whatever thing was here now is no color. We can go to index 3 and replace whatever thing is there with the null. You remember in the previous class, we learned that list supports nulls. So you can essentially set something to a value of null, and we see that there's still a position available. We can call set on index 4 and replace that with the null. And if we did that, of course, so now we have maroon, we have blue, we have no color, we have null, we have null. But if we were calling add on this, the array list would grow, would shift the elements, and the array list would continue growing. So to see that in action, let's call colors again and say I'm adding to a non-index like 2, which we know has now been replaced with this. And let's say we are adding blue again, and let's just do the same thing we did with set. Let's just go to 3 and go to 4 and add be blue. Let's add green. Let's add pink. Pink. And if we run it, we'll see that our array list is now bigger. because these set operations were not changed. We still have no color, we have null, but now we have green, we have pink, we have blue twice, we have maroon. So that is the difference between add and set. If you are calling set, you are doing a replacement operation. If you are calling add, we are shifting the elements inside the array list to create space. Yeah. Any question on that, on the set function? Or comment, maybe something I missed. So I don't know if set has any other variant function. I think, yeah, it's just you pass in an index and the elements. So this is essentially how you use it. Also, if my screen stops showing or my audio drops, kindly let me know, because I won't be able to tell from because I'm just looking at the ID, so I won't be able to. Okay. So no question on this. Wonderful. Let's look at the other operation then. We'll create another compact file. Let's call this ArrayList session 2. Dot. I don't know if I can use dot, but I can use underscore. And this is a Java file. Again, I keep forgetting. Yeah. And we'll have a void main function, and we can proceed. So we've looked at set, we've looked at add, we've looked at get. Now we are going to look at another operation, which is, this one is more from the collection interface, so it won't be new to you guys. This is the remove function, which remove has plenty of variants. Some of them we are not even able to cover now because you need some knowledge of functional programming. So we'll just look at the ArrayList specific implementation. So just like the name, use this to remove an element. So difference from the set function is this doesn't do replacement. This just completely removes the value, which means there's shifting happening by the. So when you remove a value, remember insertion order is preserved from our initial class. So when you remove something, the ArrayList itself will rearrange so that you can still refer to indexes correctly, which I think we'll explore with this and see what happens. So I'll make another list. This time we can be a bit more creative, be something less basic, and let's go back to our tradition of ice cream flavors. So I'll have a class ice cream flavor. I'm sure you don't have that in the code base. And this instead of class, let's use a record. So a record is a way to create shorthand classes that you don't have to have getters and setters. There's additional things about records, but we'll cover them later. For now, just imagine this as a way to quickly create a class that has the getters and setters without you having to write them. But there's more to the story. So in this ice cream flavor, it just has a name. The flavor has a name, and maybe let's give it as okay, let me not complicate it. Might steal the show. So now we'll create our array list of ice cream flavors, and we'll call this flavors is equals to new array list. And we'll populate it with some flavors. So we'll add a flavor, new ice cream flavor, and the first flavor we have here is vanilla. So I'm using control command D, which I think is in Windows is probably control D or something, or Windows D. So it's a shortcut that you can use to duplicate elements. So if you press it like so, you'll be able to get like elements created in new line. Just in case. I guess I don't see that. So vanilla, then we have strawberry, and we have maybe mango. Yeah, mango. Okay. So this is our array list. We can go ahead and print it just to be sure. Flavors is flavors. And if we run this, we should be able to see the list of flavors. So vanilla, we have strawberry, we have mango. So then the next thing we'll do now is let's try to remove one of these flavors. So to remove a flavor, we can call remove and pass in. So there's two variants. So we can call remove, and the first remove it receives an element, the element you want to remove. The second remove, just like we saw with the other cases, you can pass in an index. You can say remove at this index. The third remove, this is borrowed from the, it's kind of similar with the get first and get last function, which is remove first. And the other variant of this function is remove last. So you can remove first element, remove last element, and so on. So we'll explore each of them one by one. So let's start with removing an element. So if we go ahead and remove new ice cream flavor, vanilla, I hope we don't run into any problems with it. There's some comparison functions that we might have to do. If we run into problems, I'll just go back to using primitives. So if we remove vanilla, okay, looks like we would be having issues with that. So if we remove vanilla, we now are left with strawberry and mango. If we remove strawberry, we'll be left with mango only. So by passing the element itself, it will compare the elements, and if they are similar, if it's the same element, then they'll be able to internally, the array list will be able to remove that element. So one thing you should also notice is the shifting happening. So the array list itself has reduced in size. Capacity, different story, but the size has reduced as we remove the elements. So then let's explore other remove capabilities. And let's say we want to remove by index. So I'll just, I like to keep some of these implementations. So we know that there's still one element left here. So let's say we want to remove at a specific index. Let's say we want to remove at index 0. Index 0. That means I might need to get rid of this to make it clear that that's what you've done. So you can call remove, then you pass in the index. And if we run that, we'll see that, so our index 0 element is vanilla. So we've removed that, and now we start with the strawberry and mango. So it has also done that shift operation, and now the element at index 0 is now strawberry instead of vanilla. So you can pass in any index essentially. So let's explore other variants of this function. Let's see if we remove, so there's remove first, which remove first just does this without the need to pass an index. It goes to the first index and removes it. And if we run it, I think we'll get the same. Yeah, we get the same result, which is vanilla, which is that the index 0 is removed because we call this remove first. If we call remove last, you can imagine this should go and remove the last element. The last element we have is mango, so it will go ahead and remove mango from the array list. Yeah, so those are the variants. There's another variant that we won't be able to cover here because of some functional programming things. And so far, we've only talked about object-oriented programming. So Java also supports functional programming extensively, and that support has been increasing with time since Java 8. So there's a few things that we'll need to learn here before we can explore this function. And you'll see this trend with some of the functions we'll be looking at later. We are not able to explore some of them because we need to discuss some functional programming construct or ideas like functional interfaces and predicates and consumers and producers. But we haven't gotten to that. So I prefer we just cover it as a separate topic, which I think every person in the organizing team also thinks the same. So so for now, just know you can use this, but there is more potential. There is more potential that you learn when we do functional programming. So this is how the remove function works. Does anybody have a question on remove? I'm seeing there's a message index out of, oh yeah, yeah, so that was correct. Is the class session beginner friendly? Yes, Cynthia, I don't know if she's still here. Yeah, it's supposed to be beginner friendly because we began with basic concepts. So every year we begin with an introduction to Java. We cover variables, we cover strings, integers, doubles. We basically introduce all the beginner topics, and collections essentially is still a beginner topic. We haven't got into intermediate. Intermediate would be now the functional programming things. So, but also if my teaching style is not beginner friendly, you can also let me know so that I can improve. Yeah, if you're not like getting something, let me know. Maybe I can reconsider my style. So are you guys getting like what we are covering? Do a thumbs up if we are in the same page. So Regan is getting. What about you guys? Okay, Dennis. Okay, awesome. So yeah, if by any chance we are not in the same page, just ask questions. Yeah, and we'll be more than glad to answer. These classes are essentially supposed to be interactive, so it's not just me just talking and talking and talking. It's you guys. So when you keep quiet like that, the feeling that I get is what I'm teaching is so clear to you guys that I can just continue to zoom through it. But if you guys have questions or something is not clear, my hope is that you just ask, and yeah. And anything, if you don't know what this list is, what these brackets mean, you can ask that. Although most people are quiet because we covered it in the generics class, and we covered the idea of interfaces. So when I say interface, I'm sure a majority of you like know what I mean. Yeah. So I'm saying we still have a bit of time. So let's go ahead and cover more basic operations. And now we'll be diving into this indexing thing. I think we'll be looking at the last part of indexing, which is additional capabilities of indexing. So for this, I'd like to preserve this also for you guys if somebody wants to go through it after the class and recap and look at the code samples. I don't like deleting things. I'd rather just comment them out. But if you want to go through it, I'll share a GitHub account, GitHub repository with all this source code. So let's continue our exploration of ArrayList, and I'll call this ArrayList session v2 underscore 3.java. So I'll create the main function there. See, the ID is assisting me. And now we are going to look at additional indexing capability. One of the indexing capability we are going to look at is this function called indexOf. And we're also going to look at last indexOf, which should be interesting. So let's start with the indexOf. So we'll create a simple list here, and this will be a list of, what haven't we used? Let's say it's a list of doubles. And it's a list of latitude. Maybe you have like a map reference system, and you're referencing like a geographical information system, and you're working with the latitudes and longitudes. In fact, let's make that real. So we have a record which is location, and you know the way you can triangulate somebody's location is by using latitude and longitude. So this is latitude and a double longitude. So long is reserved keyword in Java because it's a type. So I'll need to get creative. Longitude, maybe just use the full name, longitude. So latitude and longitude. Latitude. So that is their latitude, that is their longitude. And this record or this class can help us to triangulate them. And we'll create a list of locations. Let's say these are locations where some event is happening. So we'll create a list of locations is equals to new array list. And these locations are, let's add the first location. This location, latitude 45 point that, and longitude maybe 23 point that, whichever that is. You can add additional locations. I'll use that keyboard shortcut to generate more of this. So you can have 67 point that, and have 22 point that, then we have 11 point that, and we have that 42 point something. Make it interesting. Okay. So this is locations. We don't know where these locations are. So let's just print them out. And locations. If we run this, we'll see that we get our locations here. Latitude, that, longitude, that, latitude, that, longitude, that. So there's a bunch of them. Let me make this short so that we are able to evaluate them when we do these operations. If the numbers are too convoluted, we might not be able to see what's happening inside because the numbers might make our vision a bit foggy. So let me keep them simple a bit. Maybe this is 45.1. This is 2.1.